All right, so let's jump into part 4. In part 4, we're actually going to talk about 8.3 and start our journey on securing the cloud. So we'll look at fundamental cloud security principles and we'll look at best practices in cloud computing. So let's jump right in. First of all, when we discuss cloud computing and security, cloud computing continues to grow. More use of cloud, IoT devices using cloud, a ton of video. Think about all the people, in my neighborhood, every person has one of those Ring doorbells or a cloud doorbell, all of that data being stored in the cloud, right? So as more use of the cloud, of course, our threat vector continues to increase. And remember that, those IoT devices are using cloud in the same data centers as companies that are utilizing it for financial purposes, for secret stuff, for prototype projects, etc. So if there's that vulnerability into the infrastructure, not just into that instance that's holding your videos, for example, we have threats. Okay. Now, what may surprise you here as we start this is, first of all, cloud security involves strategies, policies, and technologies designed to protect data, applications, infrastructure within cloud. Okay, so now we're talking about securing that data. We've talked about redundancy, we've talked about latency, so now let's secure these endpoints that are storing all of this great data. So 39% of businesses experienced a data breach in their cloud environment in the past year. So this was in 2023, okay? A 4-point increase from the previous year. 75% of businesses report more than 40% of their cloud stored data is sensitive. Okay, 40% of it is sensitive, up to 26% from the previous year. So again, more sensitive data is being placed in the cloud, which means it's a higher target. It's a larger threat vector. Only 45% of sensitive data is encrypted on average, highlighting a significant gap in cloud data protection. Now remember, this may not fall just on the provider. This may be on the client. Remember, anytime we encrypt data, we increase the time it takes to process that data, to read that data, to decipher that data, to store that data if it's being encrypted. Okay, to do that process of encryption of data. So that's why, do we want quick response or do we want secure data? That's always a challenge as well. That's why, there's a big push to find better encryption algorithms that take less time. Securing the cloud, data protection is a huge thing. Risk management, we're going to deal with risk management in a subsequent chapter. We'll definitely take a look at it in chapter 9, managing the maze, compliance, risk management, and governance. Okay, so we're just going to bring back a little bit of things here again, as I said before, that may seem familiar, but we're going to put a cloud focus on them. So primarily, we'll be looking at protection. So principle of least privilege, we've talked about that in endpoints from an end user standpoint, only giving a user access to the information, to the applications, to the resources they need to do their job. That is hugely important here because as we store more in the cloud, there is more to access. Okay, as we store more in the cloud, we're starting to integrate a lot of these autonomous applications into one, like an ERP system, where we can store data less times, store a customer, for example, a client record one time that can be used by finance and can be used by manufacturing and can be used by service, as an example. Okay, so, importance in cloud, it prevents over provisioning, and access rights, minimizing the attack surface in scalability and dynamic cloud environments. Shared responsibility model. So this is a security framework that delineates the division of security responsibilities between the cloud service provider and the customer. So where is this all defined? It's defined in the SLA, and that service level agreement. Okay. Security in the cloud, so the CSP is responsible for securing the physical infrastructure, the networking, the hardware. The customer is responsible for securing their data, securing their applications, and implementing proper configurations of those applications, i.e., patching them for vulnerabilities. That becomes a client's issue. Okay. Now, of course, all of this changes depending on our service model. Are we getting infrastructure as a service, software as a service, platform as a service? Okay. Data ownership is a part of this. So that's where the client retains full ownership of their data, even when it's stored in the cloud. They then are responsible for it. And we see some regulations that have pushed this back to the client to be responsible for their data, which includes their own customers' data. Okay. Backup responsibilities. Clients are typically expected to implement their own backup strategies to protect against data loss, because remember, it's not just about losing an entire data center. Okay. It's about your instances getting hit with ransomware because an attacker's gained access to your instance within a data center. So the principle of data minimization. So this involves collecting, processing, and storing only minimal amounts of personal or sensitive data. So if we want to reduce our risk to an attack, store less PII. If we have personal identifiable information that we're not using it for billing, we're not using it for processing, we're not using it to, say, in healthcare, to treat a patient, then why are we storing the data? Okay, so that's what data minimalization about. First of all, it does reduce the attack surface. It also reduces the cost. If we're not putting data in that we're not using, we're not storing data that we're not using, we're not risking data we're not using, we're not backing up data we're not using. Okay, so a lot of times this aligns with regulatory requirements within industries. So we'll take a look at that as well. Security by design. So more important than ever, it's not just about securing the application. Security by design integrates security into every stage of the system development lifecycle. System, not application development lifecycle, right? From the initial design through deployment. So this could be the software development lifecycle. It starts with planning. When we plan, we build in security. We build in encryption. We have requirements around securing data, around securing the physical aspects of our cloud computing, right? Logical aspects as well, all the way down to it could say, okay, if we're going to do this, we have to also make sure we add this to our IPS or our IDS or our SIEM, okay? Which means we may incur additional cost if the SIEM is analyzing more servers, analyzing more data. Monitoring and incident response. So, involves continuous monitoring. This is where the SOC comes into play. That's primarily one of their jobs, right? Through these technologies that we've talked about that get implemented. We might also outsource this, to a service provider again, to monitor our data, monitor our network, for malicious traffic, hits, whatever the case may be, attacks, etc. So monitoring and incident response is hugely important, especially today with all the data flowing over a cloud. It's that continuous monitoring. It's a swift response to a potential threat, a potential incident. We want to make sure, is that incident legit, or was that just a patch that got installed that, created a signature that we haven't seen before that's unique? Did somebody install an application? Did somebody reconfigure a portion of the OSI model stack for the app that created a new signature that in fact is not a threat, is not a vulnerability, but now needs to be added so that we don't see that pop up again? Okay. Robust incident response plan, again in chapter 9, ensures quick containment of threats. How are we going to deal with threats? How are we going to manage risk around threats? How are we going to minimize damage? and how are we going to facilitate those quick recoveries in the case of a natural disaster, ransomware, outage of our internet service provider, whatever the case may be. So just real quick, absolutely love this book. It is in its second edition. I haven't read the second edition, but it's my understanding the author, John Vaca, has added more and updated stories around cloud security, data protection, architecture, identity management, updated it with things that are important today that might not be important yesterday when edition 1 was done. I'm constantly joking with folks as I'm writing this textbook that as soon as I finish, I've got to start the second edition because things have changed within cybersecurity. So, it is amazing how quickly things change. And, more importantly, it's not just this course, but it's reading additional material. I'm constantly consuming news articles on the latest threats, the latest changes in compliance, state law, federal law, what's happening at our government level as it pertains to cloud, data, the whole 9 yards, cyber as a whole, if you will. Okay, so this is a great book. I read the first one. I'll probably end up reading the second edition. Definitely pick it up. Here's a way to expand on this chapter's knowledge through a great read. So, security best practices, shifting back, strong passwords, multi-factor authentication. I'm not going to spend a bunch of time here, but you can understand that the risk is much higher in the web because now suddenly if that username and password was only able to be used locally on a local area network on local resources, the risk is much less than suddenly that is accessible from anywhere in the world. Now a hacker has time to do that brute force attack on a username and password within an application that is available via the web. Again, encrypting data becomes important, data at rest, data at transfer, making sure you're using, TLS to secure data, as it traverses the network and the big I internet. Other network security measures, imperative for protecting network infrastructure, implementing, the current technology in firewalls. Specifically in this case, next generation firewalls, those are really important. Bringing forth IDS, making sure your VPN has the latest and greatest encryption, strong access controls. So again, more role-based access control, which, goes along with the principle of least privilege, making sure people only have access to the data. And as we talk about cloud, minimizing, and separating the amount of cloud infrastructure that one cloud engineer is able to manage and manipulate versus another. Okay, so that, one cloud engineer does not need access to cloud applications, cloud resources, cloud networking, cloud infrastructure that they are not responsible for managing. Regular audits and compliance checks, again, very important. Ensure compliance relevancy, regarding GDPR and HIPAA, and we're going to look at those in just a few minutes. Leveraging those security tools, whether they're accessible through a cloud provider that provides them or that we implement within our cloud, within our hybrid cloud, whatever, to, again, assess data, those IPS, anything we can to bolster and shore up the security of our company's data. All right, so that is it for this part in part 5. Now that we understand some basic cloud security and best practices, we'll take a look at cloud security threats and a little deeper dive into regulations. See you then.